So at this point, I'm now ready to populate these sockets, and I'm just going to kind of work through this. I'll talk through the different pieces I'm populating and generally what those are for. And there's still, of course, some stuff that I'm not going to populate at all at this point until I can find out is what I've done so far, is this going to function? And if it is, then I'll continue with the other missing pieces. But what I've laid out here really will hopefully get me back up to the point of the previous board. And again, this is that previous board. I've taken out the extra board that was for the single ROM and the shadowing of that single ROM. And I really pulled out the majority of the ICs. I've left some in here where I had actually soldered on some resistor arrays, some SIPs just on the outputs. Those are part of what I have here on the new board. And so I don't have to necessarily worry about those right here, right now. But I pulled out all of these pieces, and that's what I'm going to load into here, and I'll talk through those pieces as I go. And my goal is to get this back up and running, just doing the basic tests that I was using with this board here. And then if that all ends up working out, then I'll continue into probably getting this VIA running next. So I'm going to start out with the processor itself. Now on this board I did orient it a little bit differently, so I'm just going to make sure that that is correct. And I might slide this down here as I'm working on it. Maybe one real quick comment. I did end up putting in a slightly different header here for power. So I do have this quick disconnect, and then I just used a terminal type adapter that is lower profile so that I can kind of keep that power connector on this lower board. I can disconnect, reconnect easily, and plug in power. And that's a 20 gauge wire, basically, or a pair of wires that's going to bring power from the upper board to the lower board. So that's kind of out of the way, simpler, cleaner than maybe what I had before, and closer to my original intention. And again, I did that because these two locations need to be offset better than they are right now. Okay, back up to this processor. I'm going to carefully get this put in. Okay, I think I got that seated without bending or breaking anything, hopefully. And so just real quick detail on this. This is an AMD, and it is a DXL. And so for what I'm doing, I specifically need the DXL, not the DX. And as a reminder, the DXL allows me to run it at a very slow clock or even pause the clock. And it basically has static operation, so I can do that and not lose what's in the registers or whatever other internal operation for it. So I am using the DXL until I get further down the road and don't need to run at a slower clock for debugging purposes. But that is an AMD, and that is capable of 33 megahertz, the one I've got there, which I will never get to that speed, but that's what the processor is capable of. From there, I'm going to go ahead and plug in. I have two PAL chips, and these are using essentially the logic that is in the hardware reference guide for the 386 that comes from Intel. And so I have a pair of ICs that are going to help me with that. And these are GAL 16V8D, and I'm using the 7LP. So these are the fast, I think the fastest ones you can get. So the 7LP. So that's what I'm using for these two. And I've got previous videos where I've gone through and programmed these, and I have the logic that I'm using on these also posted on my blog. So I'm going to go ahead and get these put in. And maybe one thing I'm going to use as I go through some of this is some of these, as I pulled out, maybe pins didn't get quite perfectly straightened. So I've got this little tool that helps me do that, which I love this tool. But let me get this first one in. And once you know it, I put it in backwards. Yes, I did. So that's something I have to just kind of be careful of. I try to, when I put these sockets in, there's a little indentation on one side. I try to always put that towards pin 1. And then typically you'll see that my silk screen hopefully is oriented so that as I read any of these, pin 1 should always be on the lower left of the silk screen what I'm reading. Same with maybe the identifiers of the chips above, so same type of thing. But I'll just have to double check I don't put any of these in backwards as I go. And if I get any of them wrong, I'll find out quickly when I apply power, because my power supply will go into protection mode quickly if I've got those backwards. Not that I've ever done that before, of course. Let's see, the next piece I might put in after these two PLD chips is the rest of these, and these are it's a PSOC, it's a 5LP prototyping kit, and it's actually labeled as a CY8 CKit-059. And so this has a small PSOC on it along with, it comes with the other piece to actually do the programming and do debugging and things like that. But I'm using this essentially as a simplified way to build out some logic instead of a bunch of discrete 7400 series ICs. I'm not doing any programming on any of these PSOCs. It's really all just a logic diagram that I'm implementing within it and treating it like a replacement for a bunch of 7400 series types of chips. And there's 3 of them. And so if I look at the first one here, this is the one that I pulled from my previous prototype board, but this would be the one generating specific signals I need, like the S0, S1, etc. And I've got that situated down here, so I'm going to go ahead and get that put in there. And then the second one is doing a bunch of just address decoding. And so this is going to take care of when I need to enable, RAM chips, ROM, IO, things like that. And this one I have situated then right here. And again, I've tried to silk screen it so that I don't forget the component I'm using didn't actually have this silk screen showing the orientation. So I added that because these are really easy to put in backwards, especially since they're not all facing the same direction on this board. And then the third one, this was a PSOC that will take the single RAM chip, and when I turn on the system, copy RAM across the copy of the ROM, sorry. So I've got my ROM chip, it copies the ROM across the 4 RAM chips. Basically shadows my ROM into RAM. And that way I can get the performance benefit of it being across 4 and not just a pair of ROM chips, or somehow trying to hack my way making a single ROM chip actually work. So the normal design from Intel, you'd either have 2 or 4 of these, and the other option is to do kind of what I'm doing here, is to shadow it. So I will get maybe my ROM and my RAM in here real quickly. And so when I take a look, this is my ROM chip. And this is, as far as what I'm using, it's a multi-purpose flash ROM. It's a 1 megabit, so that's megabit. So divide that by 8 if you want to get megabytes. And so basically this is 128K that I'm working with. And it's an SST39SF010. And for now, this is a -70 as far as the speed rating is concerned, which for now is plenty good for me. And even when I get done with this, that's probably what will be in here. I think you can get slightly faster ones like a -55, but I'm doing it's an SF010-70 is what I'm using. And then when it comes to the RAM chips, I have 4 of those, and these are AS6C4008s. So these are a 512K by 8-bit. And so I'm going to go ahead and get these put in. This is essentially giving me 2 meg of RAM. And in that RAM, of course, I'm taking up part of it for the ROM that gets copied over. I'll have some IO address spaces, things like that. But I'm going to go ahead and get this situated and in. these I did pull from the other board again, so trying to get these all straightened out, make sure I don't have any pins that are too far out of line. Okay, so those are in. Just going to take a quick peek from the side. I don't see any bent pins, so I think we're sitting good there. And make sure I got these all oriented to the left. Yep. Okay, so that takes care of my ROM and RAM. I have one tiny little IC here. This is just a little 8-pin. This is a DS1232, and it's a micro monitor chip. And I have that situated right up here. So I'm going to go ahead and put that in. Now, what this is really doing in this design that I'm using is it delays taking the system out of reset for a small amount of time. So when power is applied, it really keeps my processor in reset and gives the rest of the system time to just at least get power and start initializing before the processor starts running. And even the processor, I believe, and I'd have to go back to the reference material for it, but it expects that you keep it in reset for a period of time. And this takes care of that for me. So that's a handy little chip. Someone at one point recommended I look at that DS1232, and I love that little chip. So that'll probably be in all my designs until I find something better that does that. It does do other things. It does also monitor. You can have it monitor a signal. I just have a clock running to it that if for some reason that signal doesn't have activity on it for a period of time, and it's a very small period of time, it'll then auto reset the system. And for now, I'm just simply running that to a clock. I do have a bunch of jumpers around that, and I'll have to fill these in later, but these have to do with a few different things. I can bring in an external reset signal if I want into this. I can bring in an external clock signal. I also have options for where do I actually run that monitoring signal. Where right now I'm coming from a clock, but I could maybe pull something different in my logic that comes over here that is used kind of as this watchdog type of thing. And just some other options that I can choose how this is configured. That's what some of these jumpers are. So I'll have to come back in a later video and actually get these configured the way I want them, the ones that require jumpers. I'm not going to do that right now. So then beyond that, I have a whole bunch of transceivers and latches. And so if I take a look at this for I'll start with maybe my latches, and those are 74 573s. And I think I have 5 of those. So I'm going to have some data transceivers down here. And then on my silk screen, I can see I've got a 573 here. I've got one here. And then over here I have, let's see, these are all 245s, and these are all 573s. So I've got 2, 4, 6, and so I might be short one of these. So I might have to grab one more of these real quickly here. So we got a 573. Let me get that in over here. Now, as far as the family, when I get into these 7400 series, I'll have to do some cleanup later. So I recognize that I don't have everything matched exactly the way I should or will end up. But for now, it's going to be good enough. And this one, I'm actually using an AS. So this is a 74 AS 573. And I'm going to go ahead and get that put in here. And then I have another one sitting right here. And my silk screen on this board is probably leaves plenty for improvement. I didn't put a lot of energy into the silk screen. Later, probably the next revision, I'll put some effort into silk screen updates. And then, okay, I've got these 4 here, so I need to grab one more of these. Okay, grabbed another one of those. Let me just get these in. Okay, so that should take care of the 573s, my latches. So then I have data transceivers, and those would be the 74 245s that I'm using. And so I have a set, let's see, 4 plus 3. I should have 7 of those. And the specific ones I'm using here happen to be an HC. And I think that is okay. That's what was in my last proto board. So for now, at least, that's what I'm going to have in here. And so let me go ahead and get all of these put in. And I do have some of these oriented in different directions just because of where signals were coming in and going out. It was more for routing benefit, routing my signals, but I just have to be really careful. You know, the capacitor should be on the pin 1 side of the chip. And you're going to see here that I've got this one facing left, that one facing right, this one facing right. So again, I just have to pay attention. Maybe when I get to a 4-layer board, I can clean that up and have these better oriented. Okay, so that should take care of my data transceivers. Now each of these data transceivers, you know, basically can handle 8 bits, and of course I've got 32 coming out of the processor. But then I also have a set that I need to use to basically get my shadowing done. So these 3 were to support that shadow using this PSOC to grab the ROM into RAM. And the way that that is done, I need to get all 4 bytes of data onto the lowest byte of this bus, essentially. So these are helping me do that. And I've got a different video where I talk about that single ROM, so if you're interested in more about that. So then we're getting down there, and I have a handful of other chips here that are really just supporting my logic, or maybe keyboard input, or other just miscellaneous. So let me grab those. And so the first one I grabbed here is a 7474. So that would be a flip-flop. And that I have sitting right here. And that's used for a couple of things. Again, I have the schematic from the previous prototype board posted on my blog, and I'll get an updated schematic posted. This does have some changes to it from that, but a lot of this logic is probably in that schematic, or will be in an updated one that I get posted. So that's the 7474. Then I have a 7432, and that would be a 2-input OR gate. And I've got that sitting right over here. Let's see, then the next one I grabbed here is just an inverter. So this is a 7414. So that's a hex inverting Schmidt trigger. And I'll go ahead, and I think I've got that in the upper left here. Okay, so that is getting down there. So then I have a 7402, and that is a 2-input NOR gate. And the 7402 I have situated right here. A couple of these are really for supporting the keyboard input. Or actually, it's a keyboard auto reset is what I've got. So when I turn it on, it resets the keyboard automatically. And then finally, I've got a 7420, and that would be a 4-input NAND gate. And I think I just got one spot left, so that should check out as my 7420, and it does. Okay, so I'm going to just take a quick scan over this, and as I look at this, seeing if I'm missing any of the stuff I expect to have filled in. So what don't I have filled in at this point? I have some additional ways to connect power. I have a spot for an Arduino Nano that'll be for keyboard mouse. I have keyboard mouse physical connections. I have my math coprocessor. I have this VIA versatile interface adapter that I have not socketed yet. And along with that are headers to connect up additional SPI devices. So built into the board, it's going to connect to, for example, this Nano for communication. On my previous board, on previous boards, I guess I've also had an SD card, things like real-time clock. That stuff has not been added yet, but those will just simply be SPI communications. So if I can get this working, then on a future revision of this, I could put a real-time clock down here and connect through SPI for that, or place it up somewhere up here. That's fine. So real-time clock would be one thing. Any other SPI type of devices this is going to control. And in addition to all the SPI signals, for additional expansion, I also have just some VCC ground headers so that I can add or connect power to any extra maybe devices I place up top. Priority interrupt controller, I'm not worried about interrupts yet, but when I get to the keyboard mouse, I'm going to have to make sure that interrupt controller is working. I'm also using this VIA for timer functionality on the board, so that'll also require that that pick is put in place and working, along with some other things that I have. But keyboard, mouse, and timer are probably the big things that I need to get this and this populated and working. Other than that, I don't think I'm missing anything that I can see. So that's probably where I'm going to get close to winding down this video. I'm not going to apply power to this yet. I do want to take this off camera and just double check I got all the orientation right as I put these in. I have before put in one backwards on previous builds just because I wasn't paying enough attention, or maybe I had the silk screen for some reason screwed up. So I'm just going to double check before I apply power to this that those are all oriented correctly. Let's see, I mentioned I got to get these jumpers done yet. Maybe one other note on these P-socks that I'm using. These are not exactly as they come out of the box. There are some surface mount capacitors that are added to this on certain GPIO signals. And it's so that these P-socks support like touch type of input, so like touch sensors. The bad thing is with those capacitors on there, if I want to use it for any high-speed signals, those GPIO pins, it will not work at high speed. So I've gone in and removed probably about half a dozen surface mount capacitors on each of these to strip off those capacitors on some of those GPIO pins where they were there for that touch type of support. So that is it. If you see something I missed here or have questions, drop a note below. But next step, like I mentioned before, is I'm going to just off camera, just double check. I've got orientation of everything. I'll just triple check that with my schematic and not trust just the silk screen on the boards here. And then I'll do some quick ohming out, make sure I don't have any short between VCC and ground. And then I will apply power and just see if turning that on, see what kind of load it draws and make sure I don't have any issues there. I'll probably then also do some voltage testing around the entire board now that this is more populated. Still not fully populated, but it's enough that I'll be able to see, am I going to have voltage issues either over here or down here or wherever it might be. And if that all goes okay, probably next steps is I need to get this debugger connection working. I'll do some quick oscilloscope probing and just make sure it looks like things are generally putting out signals that I would expect to see, but I'm not going to have a good feel for what it's doing until I get this debugger set up. So I want to get that in to at least read out my address. I can pull data from here and control signals from a couple of these, but I need to get 2 PCBs built, and that'll be a separate video that maybe in a week or two I'll post about building out these add-in cards. to connect in and get those signals over to a small debug board that will go to a Teensy over to my PC and see if I can get that whole setup working. Pretty much that whole setup minus the software I wrote for Windows is going to be pretty new. The way I'm connecting, the way I'm going through a Teensy. But I will talk more about that specific setup in a separate video. And if I make it through that, then the next step will be I do want to get my Agilent Logic Analyzer connected, and that's a separate add-in card that will go into these slots. And so that might be a follow-up video after that. And then, of course, getting back to this VIA, connecting to this Nano. This Nano has a little OLED screen, so I can do some output of how the post tests are working as I turn on the system or whatever initialization I want to put there. And at that point, I should have, if things go well, I should be able to communicate from the system to my PC through basically SPI to this Nano and then serial, USB serial to the PC. So I'll essentially have a terminal on the PC, in addition, of course, to the debugging that I'm doing down here. So I'll have the debug output, plus I'll have a terminal connection that goes through that. So thanks for watching, thanks for following, and as always looking for feedback on how to do something better. With all of these videos, I'm learning something every single video. I definitely am not coming in with this knowing everything ahead of time. And so you'll probably see some things that are going to work here and some things that are not going to work, and I might have to make some minor or major adjustments. But always appreciate the conversation below and all the great advice and recommendations I get from people. And I love the questions too. And I'll do my best to answer any questions that anyone might have.